Welcome students. Today I discuss about the Wolff rearrangement. Now using Arnold-Ester synthesis process we can synthesize a homologous acid as shown here. Starting from this carboxylic acid we can synthesize a homologous carboxylic acid of it. So what is the process? First this carboxylic acid is treated with SOCl2 and forms this compound, which one treated with diazomethane. Here when R2 equal to hydrogen, the diazo compound becomes a diazomethane and it generates this compound, which one treated with silver oxide or on photolysis generate ketene. When this ketene treated with water, it forms the carboxylic acid, which is a homologous carboxylic acid of the starting carboxylic acid of this process. Now when we used RXH instead of water, we get these types of compound. When X equal to oxygen, the compound becomes ester. When X equal to sulfur, the compound becomes thioester. When X equal to nitrogen, we get N substituted amide. Now the conversion from alpha diazoketone to ketene is called the Wolff rearrangement, and the process takes place either by the concentrate pathway or by the stepwise pathway depending upon the configuration of the alpha diazoketone. When the alpha diazoketone becomes the SZ configuration, it followed the concentrate pathway, and when it is SE configuration, it followed the stepwise pathway. Now when the alpha diazoketone is in SZ configuration, its resonating structure is as we can draw on this negative charge of the nitrogen come here. Consequently, the CN double bond comes there and the CO double bond comes and generate this resonating structure. When the negative charge of the oxygen back in this way, then the R1 group migrate to the carbon containing the N2 plus group, and consequently nitrogen leaves from the compound and generate carbene. Now in the stepwise way, when as we mentioned few minutes ago that AC configuration undergoes stepwise way follow the stepwise way pathway, and here one of the resonating structure is this. Then the diazo group leaves and forms the carbene. Then the migration takes place in the following way, and it generates the carbene. So when a alpha diazoketone which contain a chiral center attached to the carbonyl carbon is subjected to Wolff rearrangement, then in the final product of the Wolff rearrangement, the configuration of the chiral center remains intact, which indicates that the alpha diazoketone are in SZ configuration. So it follow the concentrate step pathway. If stepwise pathway follow, then mixture of configuration takes place of the chiral center. So using Arnold-Ester synthesis process, we can synthesize a homologous carboxylic acid. As shown here, this carboxylic acid can be synthesized from this carboxylic acid. So what is the retrosynthesis process? First, this compound, from this compound we can get the our product, which can obtain from the benzoic acid. So in addition to this, we also synthesized this carboxylic acid from this alpha diazoketone, and the reaction mechanism of this pathway is that the one with the resonating structure of the alpha diazoketone is this one, then diazo group leaves and forms the carbene, which then undergoes migration in the following way and generated a carbene, generated a ketene. Then the water molecule attacked this carbon and generated our desired carboxylic acid, and the alpha diazoketone obtained from this carbonyl compound by deformulative diazo transformation. So how can we synthesize this compound starting from this compound? Now when this compound treated with SOCl2, it generates this compound, which when treated with excess diazomethane followed by the treatment of silver oxide in presence of water generates our desired compound. And how can we synthesize this compound from this compound? First, this compound, the starting compound, is treated with SOCl2 followed by the treatment of diazomethane. Then the compound alpha diazoketo compound treated with silver oxide in presence of methanol generates our desired ester. Now when this alpha diazoketone on photolysis, it generates this ketene, which on treatment with water forms this carboxylic acid. So how can we synthesize this compound starting from this one? First, this compound treated with NET3 followed by ClCOOET and then treated with diazomethane. It generates the following alpha diazoketone compound, which then treated with CF3CO2Ag in presence of NET3 and water generates our desired carboxylic acid compound. Now when a alpha diazoketone on photolysis forms a ketene, which on treated with N-substituted amine, it forms the N-substituted amide, which on treated with lithium aluminium hydride generate a aldehyde. The desired aldehyde we can also obtain when the ketene treated with a thiol, which on treated forms a thioester, which on treated with ranitidine forms the aldehyde. Now when this alpha diazoketone subjected to photolysis in presence of a dienophile, the ketene which is formed undergoes intermolecular 2+2 cycloaddition reaction, and consequently it forms the following compound. Similarly, when this compound is subjected to photolysis in cyclohexane, this compound first forms the ketene, which on undergoes intramolecular 2+2 cycloaddition and generate this compound. So how can we synthesize this compound from starting from this? First, this compound on treated with diazomethane forms the alpha diazoketone, which on subjected to photolysis forms ketene and undergoes intramolecular 2+2 cycloaddition reaction and generates this compound. And when this compound treated with HCO2ET in presence of sodium methoxide followed by treatment of TSN3 in presence of ET3N forms the alpha diazoketone, which when subjected to photolysis in presence of methanol forms the ester. So students, if you have any query regarding Wolff rearrangement, feel free to comment in the comment box. Thank you.